Let's talk about elements, compounds, and mixtures. So here's how you use this video. Throughout this video, when the slides come up, there'll be some text that's highlighted in green. If you're using this to take a notebook, that's what you should write down. Those are the important ideas. There's also going to be text written in blue. Those are questions for you to answer or for you to consider. Now, throughout this video, there's going to be one visual code that'll pop up on the screen, one verbal code that will be said by myself, and those can happen in any order, so pay attention. But let's get started. So, matter. Matter is anything that has mass and takes up space. So matter is usually organized into three states: solids, liquids, and gases. Now, here are some examples of things that are not matter. So if you ask this question, hey, does it take up mass? Does it have mass? Does it take up space? You can answer no to these. Light, gravity, love. Those don't have mass, those don't take up space. Now, matter is either a pure substance or a mixture. So, a pure substance. A pure substance is a substance that contains only one ingredient. So, examples of pure substances include water, gold, diamond, and sugar. And we'll get into more of these examples a little bit later. Now, a pure substance can be broken down into either an element or a compound. And at this time, I'll go ahead and give you that verbal code. The verbal code is 332. So, an element. An element is a pure substance containing only one kind of atom. So an element cannot be separated into simpler materials. There are 118 elements in the periodic table. There's only one capital letter in the chemical formula. And here's what I mean by that. If you're looking at something like carbon, carbon is represented by capital C. There's only one capital letter. Sulfur, capital S. Now gold has two letters, but only the A is capitalized. So it's still an element. Now pure diamond is a little bit tricky because pure diamond is made up of just carbon. It's just in a crystal structure. Same thing with pencil lead. Pencil lead isn't lead, it's actually graphite, which is carbon in sheets, and that's why you write with it. Those sheets are easily removable. Now, there are some elements called diatomic elements. They can bond with each other. An example would be oxygen. Now, you'll look at these, and there's only 7 of them, and you can look at it and says, okay, O2. Well, I've got 2 atoms. But remember, the definition of element is only one kind of atom. And just as a side note, I say they cannot be separated in simple materials. Yes, there are protons, neutrons, and electrons, but we're just talking about as far as like just the materials, right? Just like, yeah, the oxygen is going to have the same chemical properties. Now, a compound. A compound is a pure substance containing 2 or more kinds of atoms chemically bonded together. A compound can be separated chemically, but not physically. So the properties of a compound are usually different from the other elements, from the elements that make them up. I'll explain this in a little bit. Now, when you're looking at the chemical formula, there's 2 or more capital letters. So here are some examples. Water, H2O, right? 2 hydrogens, 1 oxygen. Salt, sodium chloride. So it's 1 sodium, 1 chlorine atom. Glucose, you've got C6H12O6. Now, what I mean by the properties of the compound are usually different from the elements. Let's just take a look at water, right? Water is H2O. Hydrogen and oxygen, those are usually, those are flammable, right? In fact, sometimes they're used as rocket fuel, like liquid oxygen can be used as a rocket fuel. So is hydrogen. Hydrogen's like pretty flammable as well. But if you combine them together, you get water, right? Something that you need to live, and you can pour water on a fire to put out a fire because it's not flammable. Same thing, like look at salt, right? Sodium chloride. Chlorine is pretty toxic to you, but if you combine it with sodium, it's just table salt, something that goes on your food. So that's what I mean by you combine it, it's usually going to take on a different chemical property. Now, if you're not a pure substance, right? If you're matter, well, you got pure substance, but then there's also mixtures. So a mixture is a substance that contains more than one ingredient. So 2 or more elements or compounds not chemically bonded together. So here are some examples, right? So you've got lemonade. Brass, trail mix, air, like the air that we're breathing. And we'll go more into this detail because mixtures can be divided into 2 categories. We've got homogeneous or heterogeneous. Now, that brings us to this question. What is the difference between a diamond, a sapphire, and a ruby? So, homogeneous mixture. Homogeneous mixture is a mixture that is the same throughout. Ingredients cannot be physically separated. So here's some examples, right? So lemonade is a good one. So if you think about it, you mix lemon juice, water, and sugar, you get lemonade. Those aren't chemically bonding together, though. It's just a mixture. Brass. Now, this one might be tricky. If you look at that instrument up there, it might be tricky. You might be looking at that and say, well, why isn't that a compound? I've got copper and I've got zinc. Well, here's the thing. They're not chemically bonded together. Those metals aren't chemically bonded. They're just mixed together. Now, the air that we breathe, it's oxygen. It's mostly nitrogen. And you've got carbon dioxide, you've got argon, and you've got other types of gases. But those aren't chemically bonded together. It's a mixture. Now, ruby and sapphire, I put a little asterisk next to them just because it's a little tricky. So ruby and sapphire are actually the same, they're the same chemical, the compound. It's aluminum oxide, and it's structured like a crystal. So now we're getting to like gemstones and crystals, but they're the same. It's called corundum, aluminum oxide. But a ruby has chrome ions mixed in with that with the structure, and sapphire has titanium and iron mixed in with them. Now, I did put this as an asterisk, and off to the side I said you might consider this a compound because they are chemically bonded in a crystal structure. But the whole idea behind this is I wanted to show you that, well, diamonds are always going to be considered an element because they're just carbon. That's it, just structured in a crystal form. Now, ruby, aluminum oxide, but they do have those metals mixed into the structure. But like I said, it does get a little bit tricky there. That's why I put that asterisk, because they are chemically bonded into that structure. Now, let's go over heterogeneous mixtures. Those are mixtures that are different throughout. They can be physically separated. So here are some examples like trail mix. And this is the easiest one. It's the one that I always use. If you're looking at that and you're saying, I don't like the cashews, you can pick those cashews out. Same thing with like a salad or like cereal, right? So you can physically remove those. So here's how you use this, right? So we talked about, some of these are subsets of the others. So when you're doing this, you can look at this and you can say, well, does it have mass, take up space? If the answer is yes, it's matter. If it's no, it's not matter. Matter can be broken up even further. You ask yourself, how many ingredients does it contain? If it's one, it's a pure substance. If it's more than one, it's a mixture. If you look at that pure substance, look at that chemical formula, say how many capital letters does it have? If it's one, it's an element. If it's more than one, it's a compound. Now on the mixture size, you say, can it physically be separated? If the answer is no, it's a homogeneous mixture. If it's yes, it's a heterogeneous mixture. So let's get some practice here. And I'm going to do 6 for you. So I just show you how to use this. So the first question you ask, we're going to do trail mix. And I put the letters next to it because I'm just going to put the letters on the flow chart instead of writing out the words just to save time. So trail mix. Does it have mass and take up space? Yes, it does. So I'm going to put an A there. How many ingredients does it have? Well, it's going to have more than one, right? So that is trail mix. Can it physically be separated? Yes, it's a heterogeneous mixture, right? Because you can pick those apart. Now, the next one is pretty easy too, right? Does it have mass and take up space? Well, it's love. The answer is no. So I just go down here and I put, well, love goes down here, right? Perfect. Now, oxygen. Does it have mass and take up space? Yes. How many ingredients does it contain? It only contains 1. How many capital letters does it have? So like I said, remember, there's 2 oxygen atoms, but it's only one kind of atom. So that is an element. So oxygen goes here. Let's look at the next one, steel. Does it have mass and take up space? Yes, it does. Now, how many ingredients does it contain? It contains more than 1 ingredient. So it is a mixture. Can it be physically separated? No. Right? It is. Now, I put that one on there just to remind you that, hey, it's iron and carbon mixed together. They're not like chemically bonded, right? It's just going to be a mixture. Now, table salt. So yep, it is matter. It has mass, takes up space. There we go. How many ingredients does it contain? It's going to contain just 1. Right? It's just going to contain 1. And how many capital letters does it have? Well, it has 2, sodium chloride. So that is going to be a compound. And the last one I wanted to do, because that's the one where you just kind of have to know it, a diamond. Remember, that's that special case. Well, it is matter, right? It does have mass, does take up space. How many ingredients does it contain? Only 1. Only 1. How many capital letters does it have? Well, this one's tricky because you have to know that it's just carbon. It's just carbon in a crystal structure. So that is going to be an element, right? Diamond is an element. What I'll do is I'll go ahead and put up more of them. I'll put 5 more up here so you can practice using this flow chart. Now, I did 5 on purpose because there's going to be 1 of each down at the bottom, right? The homogeneous mixture, heterogeneous mixture, element, compound, and not matter. Just so you can practice using this and putting them in each of those categories. So, just remember, there is too much unknown in the universe to take a break from learning. Get out there and question everything.